Okay, so on this extra handout I gave you, we're going to see 4 different problems. And again, we're going to use each of our methods with all 4 problems. So we're going to work through them in the same order every time. For problem number 1, we've got our function up at the top here, our equation up at the top. And to factor, remember, we need everything on the same side equal to 0. We need standard form to factor. We have that here. Everything's on the same side set equal to 0. So if I'm factoring, what's going to be my very first step? I have a GCF of 3, so let's divide out that 3. So this would be x squared plus 12x plus 20. And now I'm going to keep factoring this part inside parentheses here. You can use AC method or guess and check here. Either way, I'm going to be looking for factors of 20 that add to 12. If anybody sees the factors that we want, multiplies to 20 but adds to 12, 2 and 10. So this would be x plus 2 times x plus 10. If you wanted to rewrite the middle and use AC method, you could here. If that's how you're going to successfully factor by using AC method, then use AC method. But we can use that shortcut here since our x squared term doesn't have a least coefficient. And now I'm going to set each factor equal to 0 and solve. So this would give me x equals -2 and x equals -10 for my solution set. Factoring on this one, not too bad. We had that GCF to pull out at the start, so you need to make sure you divide that 3 out of every term. That's the only kind of tricky part of this problem. But otherwise, not too bad. This factored nicely. And again, you can use AC method for this one, or what I've kind of called guess and check, that shortcut. Just make sure you take out that GCF first. Quadratic formula was our new one. Actually, let's go down. Let's go in order of what we learned. So the first method we talked about was factoring, and then we talked about using square roots or completing the square. Since our original function is not already written as something in parentheses squared, that means we would have to complete the square to get it into that format. So the first thing I'm going to do here again is go ahead and divide out that first term. And since I want to solve this, I'm just going to divide it off to the other side. So we would get this when we divide out that 3, and then I'm just going to divide it to the other side. So I'm pulling out my GCF. Really, whatever number was in front to complete the square, I'm going to divide everything by that number. And then I'm going to divide it to the other side. Because in order to complete the square, I need just x squared, nothing in front. And then when we talked about solving these, we talked about a couple different options you have. You can move the C term to the other side. Since we did all of our work in the last unit with it on the same side, I'm going to keep that same format. If you want to move the 20 to the other side, work on both sides of the equation, that's okay too. I'm going to keep it more in line with what we've done more, which is everything on the same side. So from here, since I'm going to complete the square, I'm going to split that middle term. So 12x split in half would give me 6x and 6x. And then remember, completing the square is where I add in that new c. My old c doesn't go away, it just gets kind of pushed to the back. And then whatever I add here, I also have to subtract from the end. And then we fill in the blank with our cut in half number squared. So this is going to be 6 squared. And whatever I fill in the first blank, I put in the second one as well. These first 4 terms, we factor. So if you want to factor by grouping there, that's fine. If you remember that sort of shortcut we talked about, that's fine too. I'll do grouping on this first one. So our GCF here is x, That would leave us with x plus 6. Our GCF here would be 6. That would leave us with x plus 6. Remember, anytime I use grouping, my stuff in parentheses should be the same. Since it is, I pull that out. Now that I've pulled that out as my new GCF, I write what's left over. That makes up my other factor, which in this case would be x plus 6. And then I combine like terms here at the end. So 20 minus 36 would be negative 16. And then my last step here, so that it looks like vertex form, is to write these two identical factors as x plus 6 squared. Now I've got something that I can solve with square roots. Okay, to solve with square roots, I need something in parentheses squared. I need a squared thing. So now I can move the 16 to the other side. And I get x plus 6 squared equals 16. Now that I have the squared thing by itself, we can take a square root. So I get x plus 6 equals, since I took a square root, plus or minus. And do we know the square root of 16? What? You did 16 squared. Other way. 4? You did way harder math than you needed to do. Okay, so plus or minus 4. And then I want to move the 6 to the other side. Since I've got plus or minus 4 here, that means that we're going to split this up into negative 6 plus 4 and negative 6 minus 4. Since I can actually add 6 and 4 or negative 6 and 4 or subtract negative 6 and negative 4, we want to split it up and actually give those simplified answers. So this would be x equals negative 2 and x equals negative 10. Same solutions that we got up here with factoring. Can we agree that this strategy was a bit more work than our factoring? Yeah. If you struggled with factoring, if you still struggle with factoring, but on that last test that we had, you rocked out all the complete the square, change to vertex problems, this is a little bit more work, but if this is the way that you're going to do the problem correctly, then do it this way. That's fine. Okay, so this is a good option. If you were good at changing to vertex form in our last unit. So if you're good at completing the square, that's your jam. You do that right every time. You could do that for every problem that we're going to look at. Just know that that may not be the fastest route to solve your problem. On Friday, we talked about quadratic formula. Remember, quadratic formula is negative b, or opposite of b, I should say, plus or minus the square root of b squared minus 4 times a times c all over 2a. So if I'm going to use quadratic formula, remember we need standard form, everything on the same side set equal to 0. Now we have that here. So I can go ahead and plug my a, my b, and my c into quadratic formula. So this would be x equals, change the sign on b. My b is positive 36, so this will be negative 36, plus or minus the square root of 36 squared minus 4 times a, which is 3, times c, which is 60, all over 2 times a, which is 3 here. And then we have to simplify, simplify, simplify. So as I'm simplifying, 36 squared would be 1,296. And negative 4 times 3 times 60 give me minus 720. When I subtract that, I'm going to end up with 576 under the root. And then on bottom, 2 times 3 would give me 6. So I get x equals negative 36 plus or minus the square root of 576 all over 6. My next step is to simplify that root. 576, the square root of 576, I should say, is actually just 24. So I get a nice root out of there. If you can use if it's a calculator problem that you're working on, if you can use your calculator, you can just type in the square root of 576 to get that 24. If you type in a root and it gives you some decimal, then you're going to have to go back and factor to simplify. But this one gives us a nice number, so we can just move on from there. So I get x equals negative 36 plus or minus 24 over 6. Since this simplified to a nice number, I'm going to go ahead and split these up, just like I did down here. I'm going to split these up so I can find my separate solutions. So this would be x equals negative 36 plus 24 over 6, and x equals negative 36 minus 24 over 6. Remember that plus or minus is telling you you have 2 options. Maybe I added 24, maybe I subtracted 24. Okay, 2 solutions there. So when I go to simplify this, negative 36 over 20, or negative 36 plus 24 would give me negative 12. Negative 12 over 6 would be negative 2. And then negative 36 minus 24 would give me negative 60. Negative 60 divided by 6 would be negative 10. Same 2 solutions. So far, what's been our least amount of work? The factoring, right? For this particular problem, factoring has been our least amount of work. We get the same solutions either way. Quadratic formula is not too bad to set up, but a lot of simplifying has to happen. So you have to be careful with your simplifying. If you are good at this little like algebraic, we're going to simplify, okay, arithmetic stuff, then quadratic formula might be your best friend because it works on every quadratic. It's just a lot of work. Be careful with your signs. You have to be careful with your simplifying. And then the last thing that we're going to talk about is actually the first method that we talked about, which is what if I simplify with or what if I solve, I should say, with a graph. So if I'm going to graph this, since we have our function equal to 0, that means I'm going to type this into my calculator on a graph page. And since we're equal to 0, I'm going to look for x-intercepts. Okay, so I'm going to pull up my calculator on the screen here. We'll graph this and we'll find those x-intercepts for this graph. Okay, calculator, we want a graph page here, and my function is 3x squared plus 36x plus 60. You can see one, there's the other, and remember, you never have to guess on your calculator. If I go to menu, analyze graph, 0, I can find those x-intercepts. So I'm going to click once to the left and once to the right. I find my x-intercepts one at a time, but I find them the same way. So I got negative 10, and then menu, analyze graph, 0, click once on either side, and there's my other x-intercept. So negative 10 and negative 2. Those solutions look familiar? Yeah, they're the same ones we found with all those other methods. Okay, so when we're equal to 0, that means we're looking for x-intercepts. And those x values are the same as the solutions that we found algebraically. So we had a solution at negative 10, or an x-intercept, I should say, and at negative 2. So with this one problem, we've used every single method. Factoring, not too bad out of our algebraic method, probably the shortest. And then graphing calculator, also not too bad. Okay. Completing the square and quadratic formula, a little bit longer. But again, if factoring is a struggle for you and you're not going to factor correctly, or you're going to have a hard time factoring correctly, then maybe that's not a good option. Maybe try completing the square or vertex formula or quadratic formula. Questions for me so far? Okay, turn the page. We're going to do it again with a new problem. So number 2 on the next page, our function is 4x squared equals 25. This time we're not starting in standard form. So if I want to factor, I've got to move that 25 over. So I would get 4x squared minus 25 equals 0. And now 2 terms, even degree, subtraction. This is a difference of squares problem. What did I square to get the first term? 2x, there we go. And then how about the second term? So my factors would be 2x plus 5 and 2x minus 5. Here's the part where I see people make mistakes if they factored correctly. So you got your difference of squares, factors there. Our solutions are not positive 5 and negative 5. Okay, remember you have to set that equal to 0, the whole factor, and solve for x. Set each factor equal to 0 and solve for x. So we get x equals negative 5 over 2. And x equals positive 5 over 2. So remember to set your factors equal to 0 when you solve for x. Let's take a look at completing the square. So if I want to complete the square, I actually don't have to do that with this problem. I don't have to work through the completing the square part because we don't have an x term. We have x squared, so we can actually just skip the change it to vertex form part and use square roots. So our original problem is 4x squared equals 25. We need the squared thing by itself, so we'll divide both sides by 4. So I get x squared equals 25 over 4. That's not going to simplify nicely, so I'm just going to leave it as a fraction. And then to get x by itself, take a square root. So I get x equals plus or minus. When we take a square root of a fraction, I can simplify the top and bottom separately. The square root of 25 over square root of 4. Square root of 25 is 5. Square root of 4 is 2. So I get x equals plus or minus 5 over 2. Not too bad on this one this time, right? The last one using this method took a bit of work. This one, not so bad. Why was this method faster on this particular problem? Yeah, I'm already sort of set up to be able to use square roots. We have x squared with no x term. So if I've got x squared with no x term or something in parentheses squared, that makes solving with square roots really nice. You can always complete the square in a quadratic to use square roots to solve. It's not always going to be your fastest method. Let's take a look at quadratic formula. We need standard form for quadratic formula. So from factoring, we know that we want 4x squared minus 25. But what we're missing here for quadratic formula is that b value, that x term. Since I don't see it here, that means that b had to be 0. So 4x squared plus 0x minus 25 equals 0. 4 is my A, B is 0, and C is negative 25. So as I go to plug this in, this would be x equals negative 0 plus or minus the square root of 0 squared minus 4 times negative 25 all over 2 times 4. Then I'm going to simplify. 0 squared is just 0. Negative 4 times negative 25 would give me 400, positive 400. 0 plus 400 is just 400. And then 2 times 4 is 8. So I get x equals, this negative 0 isn't doing anything. So I can just do plus or minus the square root of 400 over 8. The square root of 400 would be 20. So I get x equals plus or minus 20 over 8. We can reduce this. These are both divisible by 4. 20 divided by 4 is 5. 8 divided by 4 is 2. So I get x equals plus or minus 5 over 2. Again, quadratic formula also works for any quadratic. Was it our shortest option here? Probably not. If you were a strong factorer, difference of squares, pretty easy, pretty quick, right? Also, square roots on this one, not bad at all. If you are gonna remember quadratic formula and you were good at simplifying, then quadratic formula on this one is fine. And then finally, if I graph this thing. Now, I'm going to encourage you, if you're solving by graphing, to always graph what you have. In this case, we don't have standard form, so I'm not going to graph standard form. The more I manipulate stuff, the more opportunities I have to make mistakes. So if I'm going to solve by graphing, I'm going to graph what's on the paper. So I'm going to graph 4x squared, and then I'm going to graph 25. Okay. And then we're going to look for intersections. So I'm going to go ahead and go to my calculator, and I'm going to graph each side on this one. Again, the more you move stuff around, the more opportunities you have to make a mistake. So let me pull up my calculator here, go ahead and get rid of all this stuff. Remember, tab key brings up that equation entry line. And I want to graph 4x squared. There we go. And then I want to graph 25. The 25 didn't show up. What should I do? Panic, assume my calculator's broken. Why can't I see the 25? Yeah, it's not zoomed out enough, right? If I hit enter and I can't see the graph, adjust your zoom. I'm going to just zoom out on this one. We've talked about zoom fit before, which is sort of my favorite, but if you know it's not going to be too far away, so 25 we knew wouldn't be too far away. Zoom out works nicely. Hit the escape key to get rid of that. And then I need to find those points of intersection. I find them the same way that I find x-intercepts. Menu, analyze graph, except for instead of choosing 0, because that's just for x-intercepts, I'm going to select intersection. I can still only find them one at a time, and I'm still clicking on either side. Don't try and land right on the point of intersection. You don't need to do that. The calculator can find it for you. So I get negative 2.5, and then menu, analyze graph, intersection, try and get sort of in the middle there, and positive 2.5. Remember, we only want those x values. I'm finding what is x equal to. Okay, so that's why we're only giving those x values. So negative 2.5 and positive 2.5. So I'll sketch that little picture on my notes here like I did for the last one. So we had our parabola, our 4x squared parabola. and then our 25. And we're looking for those points of intersection. And again, just those x values. So negative 2.5 and positive 2.5. That's the same as 5 over 2, right? 5 over 2 is 2.5. So negative 5 over 2 and positive 5 over 2. Same thing. Questions for me so far? Okay, we have a couple more problems that we're going to look at for today. So on the next page, number 3, same idea. We're going to start with factoring. To factor, I need standard form, so that 7's got to move over. That would give me x squared plus 3x minus 7 equals 0. I would have to subtract the 7 to move it to the outside. And now to factor, I need factors of negative 7 that would add to 3. Negative 7 would be negative 1 times 7, or 1 times negative 7. And it's prime, so that's it. That's all I got. Which of those is going to add to 3? None of them, right? So what does that mean for factoring for this problem? It's not going to happen. I don't have factors of c that add to b. We can't factor this with real numbers, real rational numbers. Maybe it factors over, maybe our solutions are imaginary, maybe our solutions are just square roots that don't simplify, but they're not going to be integers, right? So let's try completing the square / square root method. Since I have x squared and x, I know I'd have to complete the square before I could use square roots. So I'm going to start with my sort of standard form there. I want to split the middle term. So that 3 split in half would be 1.5 plus 1.5 plus something minus 7 minus the something. And then to fill in the blanks, I would need 1.5 squared. Now, you can complete the square here and get your vertex form and then solve with square roots. But what I have noticed is that most of us struggle completing the square if our numbers here are not nice numbers. And if you're working on a, say, no calculator section, we're not going to get 1.5 squared. We struggle with that. So for a problem like this, most of us would stop and pick a different method, okay? You can still complete the square here, but as soon as we're working in decimals with factoring, we have a really hard time with that. So I would not encourage you to complete the square on this problem, okay? We tend to make more mistakes when we're completing the square with decimals. So I couldn't factor. I'm encouraging you not to complete the square on this one. Quadratic formula. So I'm using x squared plus 3x minus 7 equals 0. Remember, we always need standard form. My a would be 1, my b is 3, and my c is negative 7. So x equals, change the sign on b, so that'd be negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 7 all over 2 times 1. Three squared gives me 9. Negative 4 times 1 times negative 7 would give me positive 28. 9 plus 28 is 37. And then on the bottom, 2 times 1 is 2. So I get x equals negative 3 plus or minus, oops, I said 37 and I wrote 36. There we go, 37 plus or minus the square root of 37 over 2. Can I simplify the square root of 37 at all? No. Be nice if it was 36 because we can simplify that. But no, square root of 37, and I can't reduce 2 out of anything since I can't simplify that root of 37. This is it. This is as simplified as it gets. This is why I couldn't factor this thing, because I'm going to get goofy like square root numbers in my solution. So I couldn't factor this thing because it doesn't have integer solutions or even nice fraction solutions. Okay, so quadratic formula so far has been our best bet. Let's take a look at graphing. So I'm going to graph each side, just like I did on that last problem. So I'm going to graph x squared plus 3x, and then I'm going to graph 7, and I'm going to look for intersections. So let me pull up my calculator here. There we go. And since I adjusted the zoom on this, I'm just going to make a new document. That way it goes back to clean slate. Okay, and I am graphing x squared plus 3x. Little parabola there, and then hit the tab key, and I'm going to graph 7. And again, that's just off my graph. I'm going to do that click and drag on my graph just because it was just right above there so that I can see what's going on. And then I'm going to look for those intersection points to find my solutions. So menu, analyze graph, intersection. Oh. Click on either side. And then same thing again, menu, analyze graph, intersection, click on either side. And let me scoop this over here just so I can see the other one. Okay, so we have some big long decimals here. On your calculator, depending on how your float is set, you may not have as many decimals as I do. That's okay. But what I want you to notice here, since we've got these big long decimals, and it's not like 2.5 and negative 2.5 like we had for our last problem, that means that these are approximations. So if I want exact solutions from you, you can check your work with the graph, but you're not going to get exact solutions from here. Okay, so we'll go ahead and jot these down. I'm sketching my graph really quickly, and I will put the calculator away. So we'll do negative 4.54 and 1.54 approximately. Again, since those are decimals and I'm rounding, these are approximations. Okay. We have one last problem we're going to take a look at together today. Oh, and I just want to make a little note here. These are not exact solutions. If I solve this problem with quadratic formula, and then I wanted to check with a graph, how could I make sure that these were about the solutions that I got from here? Is there a way that I could do that? Yeah, I could take this negative 3 plus square root of 37 over 2 and negative 3 minus square root of 37 over 2. I could type those in my calculator and check. I'm going to do that really quickly before we move on. I think that's a handy thing to know how to do. I'm just going to pull up my scratch pad here, and I want a fraction And remind me, this was it negative 37? What did we just write down? I can't see my paper. There, oh, negative 3. Negative 3 plus square root 37 over 2. That gives me 1.54, blah, blah, blah. That's one of the solutions that we got. And then if I just arrow up and select this, instead of having to retype the whole thing, I just change that to minus. There's the other solution that we got. So if you want to check with the graph, you can do that and still make sure that your exact solutions are what you got from the graph. Okay, let's take a look at our last problem here for today. I've got standard form, which is nice. So if I want to factor this thing, first step, pull out a GCF. That'd be negative 2 times x squared plus 4x plus 5 equals 0. And then I would want factors of 5 that add to 4. 5 is 1 times 5 or negative 1 times negative 5. Which of those is going to give me 4? None of them, right? So this one, not factorable. With real rational numbers. Maybe I'm going to get some of those funky square roots again. Maybe I'm going to get something imaginary. I don't know from right now. We'll find out. Completing the square would be our next one. Since I've got x squared and x, I know I'm going to have to complete the square. I also know I'm going to have to divide everything by that negative 2 like I did here. So I'm going to go ahead and divide that off to the other side and start my completing the square with that next step. So x squared plus 4x plus 5 equals 0, since we divided that negative 2 off. Split the middle, x squared plus 2x plus 2x plus something plus 5 minus something. Fill in the blank with cut in half number squared. 2 squared is 4. And then I'm going to do the shortcut on this one. Instead of factoring by grouping, we're going to end up with x plus 2 squared. It's always x and the cut in half number in parentheses that you're squaring. And then combine our terms at the end. 5 minus 4 would be 1. And now I can solve using square roots. So get the squared thing by itself. That means I'm going to move the 1 to the other side. I get x plus 2 squared equals negative 1. Take a square root, take a square root. So I get x plus 2 equals plus or minus the square root of negative 1. Since I'm taking the square root of a negative number, what does that mean? Yeah, this is going to be imaginary. And what's the square root of 1? Just 1, right? So 1i, or just I if you want. So this would be x plus 2 equals plus or minus I, or 1i. Move the 2 to the other side, but since I've got something imaginary here, I can't combine it any more than saying I have negative 2 plus or minus I. Completing the square, not a bad option here. The other thing I can do is quadratic formula, right? We know quadratic formula is going to work on every problem, so we can do that here as well. So again, we're going to use our standard form, and here's our A, here's our B, here's our C. This would be x equals, change the sign on B, so that'd be positive 8 plus or minus the square root of negative 8 squared minus 4 times negative 2 times negative 10 all over 2 times negative 2. And then we simplify. Negative 8 squared is 64. And then negative 4 times negative 2 times negative 10 would be negative 80. 64 minus 80 is negative 60. 2 times negative 2 on the bottom is negative 4. So I get x equals 8 plus or minus the square root of negative 16 over negative 4. Since I'm taking the square root of a negative, that means I'm going to have I, and the square root of 16 is, is 4. So I would get x equals 8 plus or minus 4i over negative 4. 8 and 4 I can divide by negative 4. 8 divided by negative 4 would be negative 2. And then since I've got the plus or minus in front of this 4i here, the negative kind of doesn't matter. Positive 4 divided by negative 4 is negative 1. Negative 4 divided by negative 4 is positive 1. I'm going to get both signs either way. So this would just be plus or minus 1i, or just plain old I. Again, some simplifying here. You need to be careful with your signs, but we still get our same two answers. Quadratic formula works for any quadratic. If I were to solve this one by graphing, I've got standard form, so I'll go ahead and graph standard form. And go to our graph here. So we've got negative 2x squared minus 8x minus 10. Since my function was equal to 0, I'd be looking for x-intercepts. But what do we see here? There are none, right? Our solutions are imaginary on this one, so I don't have any solutions that I can see on the graph, because my graph doesn't show me imaginary solutions. There is something called the polynomial solver tool that your calculator has. No x-intercepts. There's something called the polynomial solver tool that your calculator has. I'll show you that tomorrow because we're about to run out of time here. But if I have imaginary solutions, I won't be able to see them on the graph as intersections or x-intercepts. And then one last reminder, the methods that we talked about are for quadratics, okay? You can factor any polynomial. You may need to pull out a GCF of x first, or factor it down until you have things that are quadratics, okay? I can't use quadratic formula or completing the square unless I have quadratics, okay? So I need a degree of 2 in order to complete the square or use quadratic formula.